All right, today we started working on the coordinate plane, and I had you try to figure out what is this. And I wanted you to focus on the word co and ordinate and the mathematical meaning of a plane. And this was a hint. And this is Moby and Tim from Brain Pop. And you had to record your thoughts in your class notes because this is what we're studying today. So we started by thinking about the way a picture is worth 1,000 words. And in mathematics, you can give a lot of information in a small space by using the coordinate plane. Think of how much harder it would be to describe to someone this map in South Africa as opposed to showing them the map as a picture. And think about how many words it would take to describe this picture of the snowman and a person. Whereas when we have a picture, it's worth 1,000 words because you get a lot of information in a little short space. So we looked at the graph on page 50, and it's about 118 years of snowfall in Philadelphia. And I asked you what the coordinates of the point were that were farthest to the right, and what did the point stand for. And all of you knew that you look to the right of the graph and you see a dot, and if you go down to the x-axis it tells you what year it was, and if you go to the left on the y-axis it tells you the amount of snowfall that fell in Philadelphia in that year. So the point stood for a year and inches of snowfall. We talked about some vocabulary today. This is the coordinate plane. So a plane is a flat surface that extends in all directions infinitely. And I had you look at the floor of the classroom. If you imagine the floor as going on forever beyond the walls and you can't see how thick the carpet is, then that's what a plane is. The plane has two number lines. This is the x-axis. It runs horizontally, and this is the y-axis, and it's vertical. You begin at the ordered pair 0, 0, which is the origin of this graph. It's where the y-axis and the x-axis intersect. Everything that's to the right and above the x-axis, so if I go to the right and up, that's the first quadrant. If I go to the left and up, it's in the second quadrant. If I go to the left and down, it's the third quadrant, and if I go to the right and down, it's the fourth quadrant. And we worked with this today. So I asked you to always think about, to understand what a graph's about, you should always read the title of the graph and the label of the axes. It gives you a lot of information quickly about the data. So you looked at the labels of the graph on page 50, and it gave you a lot of information that it was about different years and the amount of snowfall that they had. And then we use the graph to answer some questions about how much snow fell in 1900. So if you look in your book and you take the 1900 on the x-axis, find that year, and go up to where you see that point, and then I had you use your ruler so you can hold it out to the left and read that number that where it crosses the vertical y-axis. And I think it was about 21 inches. And the question was, in how many years was the snowfall 50 inches or more? So I had you put your ruler along the line where it was 50 inches, and there were 3 dots above the 50 inches. So in only 3 years out of 118 years did we have snowfall that was 50 inches or more. All right, and then you made a graph for yourself. These were the average low temperatures for Helsinki, Finland. And each ordered pair, each red dot, represents the average low temperature for each month of the year. And I had to scale my axes by 2s. If this is 0, I counted by 2s because I had to go to 12 months and I was off my graph. This only goes to 10 if I count by 1s. So it's okay to count by 2s as long as you're consistent. So this is 2, 4, 6, 8, 10, 12, and going up 2, 4, 6, 8, 10, 12, and going down -2, -4, -6, -8, -10, 12. And we didn't have any such thing as a negative month. So this first red dot represents January, the first month's temperature. The average low temperature was -11. And February, the second month, was also -11. And the third month, March, was -7. The fourth month was -1. The fifth month was 4 degrees. The sixth month was 9 degrees. The seventh month, so this is July and August. So now we're at the height of summer where it was the warmest. So the low temperatures, the average were 11 degrees. And the ninth month, September, now it's getting cold again, 6 degrees. The 10th month, October, was 2 degrees. November was negative 3 degrees, 3 degrees below zero. And December was 8 degrees below zero. So you can see the trend that the temperatures started off cold in January, slowly warmed up, and then went back cold again, back until the following December. So that's how you plot ordered pairs on a graph. And then I wanted you to see the difference. We related this to kind of like your address. Like if you told me your house number and your street, I would know to go to your district, your street, and go to your house number. Well, these ordered pairs are called ordered pairs because there are two numbers, a pair of numbers, and they are in order. They must be in a certain order from left to right. The 2 always represents the x-axis, the amount I move from the origin on the x-axis, and the 5 is the y-axis. So you always begin your graph at the origin. So to get to this first ordered pair, 2, 5, from the origin, I go 2 to the right and 5 up, and that's the ordered pair 2, 5. 5, 2 is a different ordered pair. I begin at the origin, and now I go 5 to the right and up 2. So the first number tells how far I go to the right if it's positive, and I need a way to know to go to the left. So the opposite of the right is the left, the opposite of a positive is a negative. So if I want to go to the left, then I have to have a negative value for x. I went up 5 in this one because the y value is 5. That tells me how much I go up or down if it's negative. And I went up 2 for this one, for 5, 2, because the y value is 2, which means go up 2. And then we looked at ordered pairs that have the same digits, 2 and 5, but are in different quadrants. So positive 2, positive 5 is to the right 2 and up 5. Positive 2, negative 5 means I go to the right 2, but now I go down 5. So it's a different, quote, address in math. So it is 5 down instead of 5 up. Negative 2, positive 5. Well, the negative 2 tells me to go to the opposite of the right, which is the left 2, and then up to 5. And negative 2, negative 5 means go to the left 2 and down 5. Notice if I connected these, I'd have a rectangle because they're the same digits, just all I did was change whether I went right and up, right and down, left and up, or left and down. But the distances from the origin are all the same. So if I go to the right and up, x and y are both positive, and that is the first quadrant. If I go to the left and up, x is negative and y is positive, and that's the second quadrant. And if I go to the left and down, notice both x and y are negative. That's the third quadrant. And if I go to the right and down, x is positive, but y is negative because I have to go down. And that's the fourth quadrant. And we usually represent these quadrants with Roman numerals. You begin where both x and y are positive, and you go in a counterclockwise direction. All right, then you actually you identified some ordered pairs, and these are the guided example page 52, A, B, and C, and the quiz yourself on the bottom of page 52, D, E, F, and G. So you can just check those again yourself. Make sure you know how to get to those ordered pairs. And then we just really focused on vocabulary. Why are these called quadrants? And a lot of you knew a lot of words that have the prefix of quad or quart. Several different languages, Spanish, Italian, have something about QUA in them for 4. Quad means 4. And what we do is we break this plane into 4 equal sized pieces. Remember, these number lines go on forever. So this is the x-axis, the horizontal, the y-axis, the vertical, and the 4 quadrants. All right, then you actually graph some ordered pairs, and this is page 53, activity 2. So you all did this yourself, and you had to plot those ordered pairs in order, and these are the ordered pairs in order. And then it said to connect them in order with a smooth curve. And I said, what shape do you get? And you guys were all able to figure out that it was a circle.
And then we checked your homework, and this was a great problem. It was the last one, number 23 for the challenge. And I just left how we found the solution here because this is a problem that sometimes kids struggle with. So you were told that a certain person had scored 23 points in a basketball game, 12 in another, 8 in another, and couldn't remember how many points they'd scored in a fourth game, but they knew that their mean was 17. And so the question was, how can you work backwards to find this missing number of points that she scored? Well, think about how you undo division. I had this sum and I divided by 4 to get 17. So if I go backwards and multiply 17 by 4, I get 68. And I know that all these numbers now have to add up to 68. So the easy thing to do is just to subtract the sum of 12, 23, and 8 from 68, or just take 68, subtract 23, subtract 12 from that, subtract 8 from that, and her fourth score was 25. And you have some to practice, so on these pages you can choose the basic or the challenge. You need to get started on your project. If you're not tech savvy, you should just do the entire project in Microsoft Word, and then when you create a new post, you just copy that and you paste it into your blog post. Make sure you do any graphs on graph paper. It has to be on graph paper in order to be a valid graph. So pick your choice. If you need time to work on your project, then just do the basic assignment.